we are going to chat inverse functions. So like, inverse just means opposite. And so what you're going to do is we got a lot of tools to help us find stuff about inverses. Now, sometimes you may have multiple options with a problem. Sometimes you may only have one. It depends. So I'm just going to kind of roll over these 5 quickly because we're going to go in depth with each of them as we go. So to find the inverse, you literally switch the x and y. Now again, y and f of x are the same thing. So if you see f of x on something and you want to change it to y equals to make it a little more sensible, that's fine. The domain and the range switch. Well, that makes sense because the domain is your x values and the range is your y, and you're starting to see a pattern develop here. You switch the x and y. You switch the x and y. To graph the inverse, we're going to do this too, you reflect the original graph of the line y equals x. Now I'm going to show you another way to do that. You're going to have 2 options. You'll kind of be able to choose which one you like better. The inverse is a function, oh boy, if the original passes the horizontal line test. So we'd always said a function has to pass the vertical, but now to see if the inverse does, we're going to turn our line 90 degrees and do a horizontal line test instead. And then the last one, I'll just explain when we get there. Trying to verbalize this is tricky. The compositions f of g of x and g of f of x are both given as a result of x. In other words, if you plug them into each other, x is all that's left standing at the end. So lots of choices. You're like, holy moly, we just need to get into this. I think we do. All right, let's start easy. Part 1. You're going to wish they were all part 1. To find the inverse, you switch the x and y. So if you have a chart, if you are given coordinate points, because that's where these are really, -2, 4, -1, 2, they're coordinate points. You're literally just going to take the y's are going to become your x's, and your x's are going to become your y's. Because if you think about it, even if you just took this first point, so if I looked at that as a coordinate point, that'd be -2, 4. But if I come over here, that same coordinate point is 4, -2. So you're literally, no matter what format your points are in, you're just switching the x and the y around. You can plot them. You can visually see it. See, like, oh, that's it. You're like, okay, let's just leave them all that way. So find the inverse of the function and then graph its function in the inverse. Okay, so I'll verbalize this one quick, but I actually want us to do these. F of x, remember, is just y equals. We even got it here. Probably should have just left it. You're going to swap the x and the y. So y becomes x becomes y, and then you're just going to solve the equation for y like you'd solve any other equation. Multiply through by 5 to get rid of the fraction. We'll kind of show that here. There's the 5x. There's my 5's canceling. There's my 5's canceling. I get y on a side by itself. And I can graph those. The nice thing about the example, which is why I even stopped to go and talk about it for a moment, if you graph both lines, okay, they're both graphed right here, they reflect not over the x-axis, not over the y-axis. They reflect about the line y equals x. It's a diagonal line that goes all the way through your graph. And so if I was to fold this grid along that dotted line, those two graphs would literally be on top of each other. You could go from point to point and say, oh yeah, so like here's 5, 2, here's 2, 5. They're equidistant. There's a word you might not have heard since geometry. They're equidistant from that y equals x line. So you should be able to see a mirror image when you do these, if you've done it correctly. So it's just another one of the tools that we have in the toolbox. So If we're going to do it mathematically, though, if we're trying to mathematically find the inverse, okay, and I'm going to kind of pick and choose the ones that I do based on complexity and some things we do. So we're going to do 3 and 4 in this section because I think it covers what we want to do best. So let me separate these. So job 1, switch x and y. Once we switch x and y, we're solving for y. So this is just me. You can get rid of the fraction now. You can get rid of the fraction later. It makes no difference. So let's say we decide we're going to do it now. So if I thought, okay, I don't want to deal with the fraction, I'm just going to multiply through. So if I do that, make sure it's all the terms that get it. And yes, even the stuff that's not a fraction gets it as well. So on our fraction, the only thing that happened was the 3 went away. And now we're trying to get this by itself, so we'll minus the 18 over. And then divide by -2. Here's where something becomes your call. If you're just finding the inverse, and you decide you're going to leave it this way, that's fine. Now, I wouldn't want to try and graph that in that form. So when you're looking at our solution manual, you might see this instead, where literally we did 3 divided by -2, okay. -18 divided by -2 is +9. Both of these are acceptable for the algebraic, but like I said, if you're trying to graph, I'm wanting to graph this because there I got a y-intercept and I got my slope right there. So just trying to make life a little bit simpler when it comes to that. But otherwise, that's it. Switch it, go to Algebra 1, and do your thing. Are there going to be some weird? Yeah, there's going to be some weird. This one I might even show you on the graphing calculator when we're done. Because you're like, wait. Okay, switch x and y. This is going to get weird. So we're trying to solve for y. Well, I got to get this y squared by itself before I can deal with that. So the 8's got to go to the other side. So we got to do the opposite and subtract it. Now, this is when the fun starts. We're going to divide by 2. I'm going to leave this as a fraction for right now. Again, you got to decide which route you want to go. Okay. Ooh. Remember, squared means there's 2 answers. Plus, minus. Ooh. Now, if we're just going straight algebra, that's fine. If you did 1/2 x minus 4 under the radical, that's fine. But you have to have the plus minus. So here's where I want you to actually be able to visually see this. We're going to see some more of this. So I'm not going to go real in depth right now. You're like, how do I do plus minus? You don't. You're going to have to literally, if you wanted to see this, you would have to go in and we're going to make 2 of these. That whole thing's under the radical. And then I do the negative of the exact same thing. So let me make sure I'm doing my due diligence to make sure I get this. Oh, dear. That's better. So here comes, we're not going to see it as well because the graph's not quite as big. So there's my little tiny piece of my parabola up here. That's my original. That's this one. Over here, those 2 radicals, because we know what a radical normally does. It's normally just this curve. So there's the positive of that. There's the negative, but it makes it look like a parabola because they are in perfect combination with each other. And if I split it down the middle at y equals x, it's a mirror image. So it looks like it wouldn't be right, but in reality it is. So trust your algebra as long as you remember things like plus minus, you're going to have to watch out for this. So, mathematically, that's how we find an inverse. So, any issues before we go back to easy again for a minute here? Not yet, and bless you. Okay, next piece. Whoops, come on down. The inverse is a function if the original passes the horizontal line test. So if you're just given a graph and you say, hey, is the inverse going to be a function? You just take a horizontal line somewhere through the middle, and just like when we did the vertical line test, if it goes through at one point, like this one did, then yes, the inverse would also be a function. But if you draw your line somewhere through the middle of your graph, and there's lots of places that that horizontal line goes through, so more than one, it's no. That's it. So when you're looking at questions like these, you've got to be careful because you've got to read, is it asking you, is this graph a function? Because that would be vertical normally. But if it says the inverse, then you're using the horizontal line test. Okay, so one word can make a whole lot of difference when we're playing with those. Okay, this is the tricky one, which is why we're going to put it in here. We're back to compositions, okay? If f of x and g of x are inverses, then the compositions, f of g of x, which means you're plugging g into f, and g of f of x, which means you're plugging f into g, both give a result of x. In other words, you plug one into the other, x is all you have left over at the end. If, though, you try one and it's not true, okay, if it doesn't equal x at the end, you're done. So like if you try out f of g of x for the first one and you don't get x, you don't have to do the other one. You're done. They're not inverses. They both have to be true for this to work. So here's what we're going to do. So on this first one, on number 10, okay, we do f of g of x first. So f of 1/3 x minus 2, because that's what g of x is. So when I go to do this, okay, there's my f function. I start writing my f function until I get to x. What's in the parentheses replaces x. Okay, that x isn't there anymore. The parentheses have replaced it. And now I'm going to simplify. So 3 times 1/3 x is x. 3 times -2 is -6, plus 6. Those cancel. I get plain old x. So we passed on the first part. F of g of x was x. So since the first part worked, now I have to do the second part, which is flipping them around. Now I'm going to do g of f of x. So I go to my g function. I'm like, all right. So we got 1/3. X is being replaced with what's in the parentheses. Don't lose the rest of your problem when you do this. The only thing being replaced is that x. Distributing. 1/3 of 3 is 1, so that's just x. 1/3 of +6 is +2, minus 2, bloop, bloop. Both are check marks. Both are good. That is 100% yes. Okay? So if I get anything for either of those besides X at the end, it's a no-go. So the place where this gets a little, actually I won't do interesting yet. Let's do 12. I want you to see one thing in basic before we go crazy here. Okay. F of g of x. Okay. So we've got, so here's f. When we get to x, we replace that. Bless you. And so we get that plugged in. A little distributing action here. So we got 10x. 2 times negative 2 is negative 4. Plus 3 is negative 1. That does not equal plain old x. You're done. No g of f of x, because we're already... Now, if that one works, could it happen where one works and the other doesn't? Yes, but that's really rare. Normally, you will find out on the first one whether you're good or not. So this is basically what's going to happen more often than not, one of those two. The only difference is we've got to be careful because there's going to be a couple of situations where the math's going to get a little funky. When we get to 11, this is just going to give us some assistance as we go here. I'll explain that as we get a little deeper in. That has nothing to do with us actually working mathematically to find the inverse. So here, same thing. F of, there's my g of x. So let's see what we get. Okay, here's f. 4 plus the square root of x minus 4 squared. You're like, well, doesn't squared and square root just cancel? Yup. So 4 plus x minus 4, 4 minus 4 is 0. That's x, that works. So step 1 passed. Let's flip them. G of f of x. So let's see here. So we got the square root of 4 plus x squared minus 4. Hardy, why didn't you put the parentheses in? Because in this case, there is nothing on the outside of them. There's nothing that I need them for. I look here, I'm like, well, 4 minus 4, so that's the square root of x squared, which is x. Okay, that works. But again, why do I need this here? So in this case, you could get yourself into a little bit of a problem if that goes into the negative, because you've got a radical, first of all, that you're also dealing with. We don't want to be negative. We don't want to deal with I. So we need to make sure that that's not going to occur. And also, if you went in to start trying to graph this within your graphing calculator, that's also going to cause a problem. Let me just pull that up for a second so we can see. Just as a quick note of reference. So, okay, if I just graphed like this, let me do this. You're like, wait a minute, those aren't the same. But remember, we're only taking the part where x is greater than or equal to 0. Now, if I get that line going through, I do actually have reciprocation. There, I spit it out. If I take the whole thing, no. If I only take this, yes. If that would have said plus minus, sure, I can do that. But that's why we've got to watch for that. So did that change anything I did mathematically? No. But it was something I had to watch out for. Just something to keep in mind. So one last one, because again, it's weird. I want to make sure we deal with weird. All right, f of g. So f of g of x. So let's see here. So here's my f. So we have got the cubed root of x minus 5 cubed plus 5. Again, the math's not going to be hard because cubed and cubed root cancel. X minus 5 plus 5, well, that cancels too. It gets me x. Okay, I'm good so far. So now I'm going to do g of f of x. So let's see here. So I've got the cubed root of x cubed plus 5 minus 5. Get that radical over the whole thing. And again, I see. Plus 5 minus 5 cancel. Okay. Cubed and cubed root cancel. We're good. Bless you. So all we're really trying to do with those, it's all algebra. We're just flipping, plugging one into the other to see if they're going to work that way. So when it comes back to trying to figure out things with the graph, because sometimes I wish I'd have done this up here when we were graphing before, but I didn't, so I can't fix. So graph the function and use a horizontal line test to determine. So let me clear this out. All I got to do here so I'm just going to kind of make a quick sketch of that. And remember, all you're doing is using the horizontal line test to test. If it goes through at more than one place, nope, doesn't work. I think you're going to figure something out here in a minute. If not, it's going to be something we can discuss. I'm going to put in this last one because I know this is going to be a shocking revelation. There's a pattern to these. Make sure I put everything in right. Yep. So something just to think about. I still would put these in on the calculator if it was asked on these. I wouldn't try to get cute. Typically what's going to happen is if you get even, because again, even we think parabola. Parabolas are not going to pass the horizontal line test. Odds, we're going to be thinking linear almost. They're going to pass. Here's the oddball though. Well, Hardy, that's odd, and it still didn't pass. What's the deal with that? Because you got pieces of both in here on that. That's why I'm going to tell you, even though the pattern works a lot, I'd still take the 10 seconds to put it in just to make sure for right now and work that out. So since we kind of discussed this up above when we were looking at this, we'll still take a quick peek because it's not going to take long. So find the inverse of the function. Again, f of x is just y, but that's not what I want to do anyway. I need to switch x and y. And I need to solve for y. Got to have the base math skills down here. Because while it's true that when I take the square root, but squared means there's two answers. So you've got to make sure you have plus minus. But just like we said before, why does this only work when x is greater than or equal to 0? Well, there's two reasons here. You can't take the square root of a negative and still have it be a function. Like, I know I can take the square root of a negative. I can pull an I out, okay? I get that. But graphing-wise, I can't do it. It's not going to be a function anymore. So that's the extra level we've got to take on with some of these. You got to stop for a moment and go, okay, does this restriction mean something? Ooh, wait, it does. And then I work that out. So, I mean, it's a lot of weird stuff, but it's not like hard stuff, if that makes sense. We're almost to the end here because, okay, good. This is the part that brings it together well. Okay. So, last couple. So, 20 and 21. This is the one thing we haven't gotten into yet ourselves. Find the inverse, then we're going to graph the function and its inverse. We're going to get to see this y equals x in action. Okay. So, that's y. So, let's do it this way. X equals 2y minus 4. Solving for y. Add my 4 over. We're going to divide by 2. Now, again, if this was straight algebra, I probably would leave it like that. But I have to graph this. So I'm going to go ahead and split this into pieces. 1x over 2, 1/2 x. 4 divided by 2 is 2. And so when I go to graph these, I'm hoping at this point we're okay graphing a line. If we're not, that's a whole nother issue. Hardy, why are you going so crazy with the dots? Oh, there's a method to the madness. And so when I get both of these graphed, going down the middle of them, okay? The line of reflection for functions and their inverse is the line y equals x, which just means when you're graphing that, it means your x and your y value are the same. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. And so what I want to look at here is that I can see the reflection, but here again is the other thing you can do, which is really cool with this. So you can start taking random points. So like, let's say I take this first point on my black line. Like, okay, that's 6, 8. If you go to 8, 6, oh, there's the same point. Okay. Here's 5, 6. 6, 5. If you just keep flipping the x and y values, you should be able to pick points 0, 2, no, excuse me, 2, 0, 0, 2. Negative 4, 0, 0, negative 4. And you should see that on every single point that you plotted. Now, do you have to do it for every point? No, but that can kind of come in handy sometimes. Here's what I mean. Here's where we're going to wrap up. Oh, boy. All right, so let's see. Switch x and y. Solve for y. Ugh. Minus the 5 over. This is going to get a little bit interesting. I can't get to the y. Well, I can't get to the 3 either. without getting that squared out of the way. So we're not giddy about this, but it doesn't matter if we're giddy or not. Well, okay, so I did the square root. Those canceled. I remember my plus minus. Well, now what the heck do I do with the 3? Do I just add it to the 5 and call this x minus 2? No. That's under the radical. This isn't. So when I go to write this, I'm going to write it this way instead so I don't get mixed up. Could you put the plus minus after? You could, but that's going to become another mess. So how in the heck am I going to graph this? We'll get to that in a moment. We're going to graph this first. You can go straight to the calculator if you want to. I'm not, because I'm like, this is in vertex form. I can do this. So 3, 5. There's my first point. Then if I use my pattern, oh dear, the pattern. 1, 1, 2, 3, 1, 1, 2, 3, 1. For those of you that are like, Hardy, I don't like you and your patterns. All right, fine. I'll do it on here too. Pluck my chart. Here we go. There's my 3, 5, 2, 6, 4, 6, 5, 9, 1, 9. Here's what I'm going to tell you. Okay? I'm going to go ahead. This is just an extra little tool to have in the toolbox just in case. Now, could I do the inverse on the calculator? Absolutely. 100%. But check this out. This is going to save me a lot of calculator button pressing. Since this is its inverse, I should be able to take those 5 points, invert them. In other words, flip the x and the y around. Flat them, so 9, 1, 6, 2, 5, 3, 6, 4, 9, 5. Where's my red pen for down the middle? And draw my inverse without putting this in the calculator. Now, if you want to, and you can, you'd have to make 2 separate lines. You'd have 3 plus the square root of x minus 5, 3 minus the square root of x minus 5. You're going to get the exact same 5 points. You just would have to piece it together. It's easier. You could have done this on this one too. Take your original points and just invert them. It's going to be so much faster than dealing with that stuff. Oh, that was the chunkiest lesson we have left. It was. There's just a lot. So, you know the drill. It's the same as it always is. In the practice packet, again, whether you got it last week, today, whatever it is, on the back table, page 1 and 2, pick odds or evens. Okay, the odd answers are on the sheet. The evens, I have a key up front worked out. So again, pictures are encouraged and expected. But if you get in